This is the first of 2 lectures on hardware interrupts for Comp 375 Computer Architecture and Organization at North Carolina A&T State University. We want to first understand what causes an interrupt and then what happens when an interrupt occurs. So, you're writing programs and your program is running along and then you press a key on a keyboard or a network packet comes in or some other program which is doing some I/O. The I/O is complete. Well, the operating system has to handle these events, but your program is running. How does it stop your program and then go off and take care of that event, then come back and run your program? Well, that's done with an interrupt. Interrupts are a way of providing immediate attention to something while another program is running. The operating system takes control and then does whatever it has to do for that event and then go back to your program. Sometimes it's required that the operating system respond very quickly. If you have 10 gigabit Ethernet, things are coming in pretty fast and the program has to do something about it quickly. And of course, some interrupts are caused by errors. If a program divides by 0 or something like that, it will generate an interrupt so that the operating system can take control, print a nasty message, and terminate your program. Interrupt changes the flow of execution. Well, there's a normal flow during your program, but if an interrupt occurs, suddenly it stops the execution of your program, goes off and runs the program someplace else, then comes back to yours. User programs are interrupted all the time. So, how many interrupts normally occur? When creating these slides, my computer interrupted about 4,000 times per second. This graphic from the textbook shows the user program on the left, where the program is executing sequentially from instruction 1 to all the way up to instruction I. Then an interrupt occurs. It jumps off and runs in the interrupt handler. And when it's done executing in the interrupt handler, it comes back and continues running the user program just as if nothing had happened. When an interrupt occurs, the hardware saves the program counter and the status flags in a special location, sometimes on an operating system stack, sometimes in a fixed location in memory. And after saving those, then it loads a new program counter value and new status flags. Of course, because it's loaded a new program counter value, it's going to start executing at a new location. An interrupt is something similar to a function call, although you don't execute the function call. It just happens, the method executes, and when it's done, it comes back to your program just as if nothing had happened. Interrupts, of course, occur at any time without any warning. Whenever something external or maybe internal happens, the hardware will interrupt, stop the execution of your program, and start executing usually in the operating system. Why not just make a function call to the operating system? The OS is not in the user's address space. Also, the operating system needs to have higher privileges than the user programs, and this switch occurs during the interrupt. When an interrupt occurs, it starts executing in an interrupt service routine, which are almost always in an operating system. The interrupt service routines figure out what happened and then take care of it and return to the user program. Here's what the operating system and the hardware generally do when an interrupt occurs. First, the hardware saves the program counter and the status flags. That is trying to maintain the state of the program so you can return to it. Then the hardware loads a new program counter and new flags. The new program counter means that the computer will then start executing at a new location. The flags also can change the privilege settings and other settings of the system. Once it starts executing, which is almost always in the operating system will save the registers so that the user program's registers aren't changed by the interrupt. And then the operating system, with some status from the hardware, figures out what caused the interrupt. and then the operating system does whatever it's supposed to do for that interrupt. And then when it's finished doing that, and sometimes all it does is it starts another task in the operating system to handle it, and then returns to the user program. And the operating system then restores those registers that it saves and does an interrupt return instruction. And the interrupt return instruction undoes that saving that it did earlier, so it reloads the saved program counter and status flags, which make it start executing again back in the user program. So here's a question for you to think about. What do user programs have to do about interrupts? The answer is D, none of the above. I don't do nothing about interrupts. You interrupt all the time. There are three basic groups of interrupts. There's external interrupts. Those are caused by I/O devices. If you read from a file on a disk and then when it's complete, it will interrupt the CPU to tell it the I/O is complete. Or if you press a key on a keyboard or click a mouse, that causes the interrupt telling the CPU that something has happened. There's also a timer built into the machine that interrupts the CPU every so often just to keep things going. Internal interrupts are exceptions that occur within a program. The program often has made a mistake. And then there are program-generated interrupts, intentional interrupts used to transfer control to the operating system. And external interrupts tell the CPU that some I/O device is done and wants the operating system's attention. Usually this occurs because something has completed, although occasionally because something is malfunctioning and the operating system needs to know that something is not working right. And again, there's that CPU timer that goes off on a regular basis. In Microsoft Windows, the timer interrupts every 15 milliseconds, just so the operating system will always get control every 15 milliseconds. Internal interrupts typically detect something that a program has done wrong. There's several other things you can do wrong. For instance, dividing by 0. Or if you have a bad pointer and you point to some address that's not in your program. Invalid instruction. That is, if you try to execute an opcode which is not implemented, you'll get an invalid instruction interrupt. There's also special interrupts for debugging. And then there's a page fault. A page fault, as we've discussed before, occurs when a program tries to access a page that's not in memory. And the page table of the user program does not have the residency bit set for that page. And so when a user tries to access that page, it creates a page fault and the operating system gets control to try to resolve that. Often, internal interrupts are called exceptions, usually exceptions because they are error type events. Program-generated interrupts are done intentionally. That's when a program executes an interrupt type instruction that causes an interrupt to occur. These are done to request the operating system to do something on behalf of the user program. Sometimes these are called interrupts and sometimes they're called supervisor calls or SVCs. The operating system has special privileges that a user program does not have, and so the operating system has to do all sorts of things on the behalf of user programs just to maintain the security and control of the system. Some examples are writing to the disk, writing to the screen. Only the operating system can do that. If a program wants to, it has to ask the operating system to do it for it. In the Intel system, there's the int instruction, which means create an interrupt. The int has a 1-byte operand, so you can tell the operating system what it is you want to be done. And then that interrupt, when the interrupt occurs, that 1-byte operand is used as an index into a table of many different addresses, so the operating system can automatically jump to the proper location to handle that kind of interrupt. An example of an interrupt here is in the old DOS operating system or command mode. It first moves the number 2 into the AH register. If you remember, AH is the second byte. AL is the low byte. AH is the high byte, the second byte of the register. And then move the character you want to put on the screen into the DL register. And then do an interrupt 21. That's 21 in hex. And that will cause the operating system to get control. The operating system will look in the registers and say, oh, O2, you want to put a character on the screen, takes that X and puts it in the next location on the screen. So what will cause interrupt? Well, the answer is all of the above. A bad pointer will cause a exception. Printing a line on the screen or reading from a disk will cause an external interrupt. That's it for now. Stay tuned for Interrupt Lecture Part 2. Another exciting lecture to be sure.